All right, lesson 5. So we are going to be working on applying the remainder and factor theorems. So sort of again, just in general, when we divide a polynomial, we take, the numerator, divide it by the denominator. If the f of x is the divisor, if you divide a polynomial f of x by a divisor d of x, you get a quotient polynomial q of x and a remainder polynomial r of x. So again, basically what that's saying is if we don't get a super nice, neat answer, we got to take whatever's left and write it as a remainder. And we do that by taking what we divided by and putting that remainder on top, and then what we're dividing by on the bottom. So we'll do an example of how to do that. We sort of set up these problems like long division, just like you would, if you think back to when you were just dividing, numbers by long division. Well, now we're doing polynomials. So it kind of works the same. So again, if we take this function right here, I'm missing a y. So again, this is my main function. This is what I'm dividing it by. We're going to set it up. So I'm going to say, okay, x squared minus 3x plus 5. And that's going to be on the outside. And then on the inside, I'm going to say 3x to the fourth minus 5x to the third. Now, when you do this, notice we went from x to the third to x to the first. We skipped x squared. So I'm going to put a placeholder in here as 0x squared to keep everything smooth and organized. So again, anything multiplied by 0 is 0. So not changing the problem. And now I need to think, okay, so my goal is to try to eliminate this 3x to the fourth. But I have to multiply whatever I think it's going to split up. I've got to multiply everything that I'm dividing it by. So I see that my highest degree is x squared. So x squared times x squared is x to the fourth. So I'm going to say, what do I need to multiply to get 3x to the fourth? I need to multiply it by 3x squared. So now I'm going to take 3x squared and multiply it here, here, and here. So that's going to give me 3x to the fourth minus 9x to the third plus 15x squared. Now what we do is we subtract these. So again, essentially what I'm doing is I'm taking this negative and I'm going to distribute it to each of these terms, which really turns all my negatives positives and all my positives negatives. So 3x to the fourth minus 3x to the fourth, that cancels out. That's great. Negative 5 plus 9 gives me 4x to the third plus 15x squared. And then when I get to the end, I have to bring down whatever I've got left. So I'm going to bring down plus 4x. And now again, my goal is, hey, I want to eliminate 4x to the third. What do I need to multiply by? Well, I got to multiply by 4x. So 4x times x squared, 4x to the third, 4x times negative 3, negative 12x squared. And this should be a subtraction. I apologize. And then the last part is going to be 5 times 4x is 20x. But because I'm subtracting, I got to distribute that negative here, here, and here. So when I go through and simplify, 4x to the third cancels out. Negative 15 plus 12 is 3x squared. This is really like minus, so subtracting 16x. Almost done. I got to carry this negative 6 down. And now I'm going to say, all right, again, I want to cancel out 3x squared. I've got to multiply it by x squared. So I am going to multiply it by a negative 3. So as I go through and again, work on canceling out or, cutting out, when I'm simplifying, I'm going to get negative 3x squared. This is actually plus 9x and then minus 15, but when I go through and subtract it, that's going to change all my signs. So I'm left with negative 25x plus 9. So this is essentially my remainder. But like we talked about up front or at the beginning, I've got to write my remainder as a fraction over what we divided by. So that would be my final answer. 3x squared plus 4x minus 3 plus with a remainder of negative 25x plus 9 divided by x squared minus 3x plus 5. One more example. Again, this one's a little bit easier because it's not, doesn't have, we're not going to be dividing by an exponent. It's just got x minus 2. And I'm going to do x to the third plus 5x squared minus 7x plus 2. And a lot of my thought process is going to be the same. What do I need to eliminate x to the third? Well, I need to multiply x times x squared. So when I do that, I get x to the third minus 2x squared. Again, don't forget you got to subtract and distribute. So that's going to give me 7x squared, bring this down, minus 7x. Oops, yep. And then now I'm going to say, all right, I got to eliminate 7x squared. Well, I'm going to choose 7x. So I'm going to get plus 7x, and now I'm going to multiply 7x squared plus 14, or excuse me, should be minus 14x. And then when I distribute my negative, it turns into a positive. So I'm left with 7x, and I got to bring down adding 2 at the end. So I'm going to get, I'm going to choose a 7. So plus 7, again, 7x minus 14. This is distributing, so I'm left with a 16. So I'm going to write my answer as x squared plus 7x plus 7, and then my remainder is 16 over x minus 2. That would be my final answer. Okay, if we use synthetic substitution to evaluate for x, so we can use synthetic division and we can use synthetic substitution. How synthetic division sort of works is, again, I'm dividing it by x minus 2. So again, I'm going to say, all right, well, that is going to be the same thing as x equals 2. So we put that right here. Our first term we take down. And now I'm going to do 1 times 2 is 2. And I'm going to put it down below and add it. 5 plus 2 is 7. 7 times 2 is 14. I'm going to add and get 7. 7 times 2 is 14. I'm going to add and get 16. Now, because it's the same problem as above, okay, and my first term was x to the third, my highest exponent was 3. When I write my answer, I have to use 1 less exponent. And these numbers are our coefficients. So I'm going to say 1x squared plus 7x plus 7. And then I have a remainder of 16 over x minus 2, which if we look, that is exactly the same thing that we got above. So again, synthetic substitution, synthetic division is probably a little bit faster than long division, but you do need to know how to do them both. All right, so let's do an example. First thing I'm going to notice is, okay, I'm dividing by x plus 3, so that means negative 3. So as I set up my problem, it's going to be something like this. I need to identify my coefficients. So my first coefficient is a 2. If there's no number, it's a 1. This has to be a negative 8, and this is going to be a 5. So now I'm going to bring my first, there it goes, 2. Negative 3 times 2 is negative 6. I'm going to add these. That's going to give me negative 5 times 3. That's positive 15, which gives me 7. And 7 times negative 3 is negative 21, which is going to give me negative 16. So because, again, my highest degree was a 3, that means I need to start my answer with x squareds. So I'm going to say 2x squared minus 5x plus 7. And then my remainder is subtract 16 and that was over x plus 3. Kind of got a little smush there. Let's make it a little bit easier to read. There. The factor theorem. Suppose that remainder is 0 when a polynomial is divided by x minus k. Okay, where k is the quotient. So again, once it equals, if it equals 0, then we know that we have a factor. That is the factor of the problem, which is, again, can be very helpful, and that's going to be something that you're going to be asked to find. So if I look at factoring a polynomial, I'm going to take 3x to the third minus 4x squared minus 28x minus 16. And I know it's given to me that x plus 2 is a factor. Okay, I know that. So I'm going to go ahead and use synthetic division. Not sure what that was. Whatever. All right. And so again, because x plus 2 is a factor, I can say that that means that x equals negative 2. So as I set up my synthetic division problem and highlight my coefficients, again, 3, 2, 1, x to the 0. We did not skip anything, so we do not have to include a placeholder. If we had skipped something, we would have to put a 0 in place. Start by bringing down negative 6. This is positive 20. And this is 16. Nice. We got 0. So that means that my factor, again, we already know that x plus 2 is a factor. And if I were to, again, take this and write it, my highest degree was a 3. So this is 3x squared minus 10x minus 8. I had a remainder of 0, so I do not need to necessarily graph it. And I can try to simplify this equation, this polynomial, even further. So I'm, again, thinking what two numbers can, multiply to get negative 8. They got to have a 3x squared, and then they got to combine to get negative 10x. When I split those up, I get 3x plus 2 and x minus 4. So again, if I were to write everything all together, I would say x plus 2 was given to me, 3x plus 2 is a factor, and x minus 4. Just write it right there. You successfully found all 3 factors. Looks a lot different than what we started with. All right, let's take a look. 1 0 of f of x is x equals 3. What is another 0 of f? So again, if I'm thinking about this one, I'm going to say, well, I should probably look at using synthetic division because I know that one of my zeros is a 3. So I'm going to set it up. And again, don't skip anything, so we're good. 1, negative 2, negative 23, and 60. I got to move this down a little bit. There we go. Bring it down. 1. 3 times 1 is 3. 1, 3 here. That's going to give me negative 20, and 3 gives me negative 60, which is 0. So again, if I were to write it, we already know that x minus 3 is a factor. And now we would say that it is 1x squared plus 1x minus 20. I'm going to think, what two numbers add to get 1 but multiply to get negative 20? And it's a positive 1, so that's going to be positive 5 and negative 4. So I would say, yeah, I've got x minus 3. Yeah, I've got x plus 5. And I've got x minus 4. So it looks like of those that are offered, I would say that the zeros are, because the zeros are negative 5, 4, and 3, and I only see negative 5. Last one. Use a polynomial model. The profit P in millions of dollars for a shoe manufacturer can be modeled by P equals negative 21x to the third plus 46x. X is the number of shoes produced in millions. The company now produces 1 million shoes and makes a profit of $25 million, but would like to cut back production. What lesser number of shoes could the company produce and still make the same profit? So I'm going to start by, again, taking the information that I found and putting it into my equation. So again, because it's 25 in millions, I'm going to say, all right, so I got 25 equals, and then I'm going to plug in my equation. And we're going to try to sort of find, we know that x equals 1 is a solution of the equation, which again, if x equals 1, because it tells us right here, okay, this is what they make. If x equals 1, well, that would stand to, be that we could divide it by x minus 1 and see if we get another 0. And potentially we could find another 0 that we could factor. So again, I'm going to use, let's subtract 25 over here. And I'm going to take this equation when I know it works, which is at 1, and I'm going to plug in. Now I did skip. We went from x to the third to x. So we got to use a placeholder of 0 for x squared. Okay. So let's see what we get. Going to kind of get the same number for a little bit. This is going to be 25, and that gives me 0, which is nice. So I got to take these numbers and, again, plug them in. I already know x minus 1 is a factor. And now I'm going to say negative 21x squared minus 21x plus 25. And now I got to think about how I could factor this. This one's going to be hard. So what does always works? The quadratic formula. Okay, again, negative b plus or minus the square root b squared minus 4ac all over 2a. No matter what, it will always work. Here's a, here's b, here's c. And so if we go in and plug it in, negative 21. I'm going to have to use my calculator. And then c is 25. All over 2 times negative 21. Negative 21 squared. Again, the negatives are going to cancel out. So that's going to give me 21 plus or minus. 21 times 21 is 441 minus 4 times 21 times 25. And a negative times a negative makes a positive. Let's keep going. 441 plus 2100, 2,541. And I don't really think off the top of my head that we can simplify that too much. So I'm just going to leave it like this. I'm going to split up my two answers. So again, I'm going to have 21 plus square root 2,541 over negative 42, and 21 minus square root 2,541 over negative 42. And if we go through that, the only positive solution, because again, a negative number wouldn't make sense. We can't produce negative shoes. So when I plug these two equations, one answer is positive, one's negative. The negative does not make sense. And the other one is approximately 0.7. So if the company wanted to make the same amount of money, they would only have to sell 700,000 shoes instead of 1 million. Think about it. The graph goes like this. Okay, here's 25 million. It could hit here or it could hit here. But either way, they are making the same amount of money, 25 million.